Hello, can you hear me? Hello, can you all hear me?
Yes, madam, we can hear.
Okay, okay, yeah. All right. Okay, so good morning, everyone. Um, so, yeah, so it's 9:06. So we have 14 participants, little bit less than usual, but that's okay. So let's get started. Let me see. All right. Okay. So we will like remind what we did last time. So we talked about time dilation, length contraction, little bit more, and also we talked about the proper time, proper length, and the proper frame. Okay. So is Arjuna here today? He had a question after our class. Arjuna, are you here? Maybe not, right? Okay, that's fine. He had a question after our lecture last time. So he asked about that same example that we did. Like, do you remember that we did an example where we had a box car which is moving at some velocity u, and we said we have the observer inside. So this is our S prime frame, and we have our observer B, and there is a instrument that can send a flashlight that will send a light pulse, right? So we talked about the event one to be the moment the light pulse emitted from the flashlight. Okay, and we named event two to be the moment the light pulse reached the rear end of the boxcar. And we had the question, we asked the question whether the observer in the S frame or the rest frame or S dash measures this time. So the time, proper time interval. We asked the question, who measures the proper time interval, right? And if you remember, we said none of them measures the proper time, because how did we define the proper time? So proper time was defined like the proper time interval is the time period between two events measured by an observer for whom the two events happen at the same position. Okay, so these two events, for A, definitely it doesn't happen at the same position because the boxcar is moving. And for B, for him also, it's not happening at the same position. And when we talk about these definitions, I thought we will discuss that again today, because it can be confusing, and we have to get the exact idea into our head. Okay, so when we say you have to measure it at the same point, they mean you have to use the same clock. Okay, so for example, so yes, this person can use the same clock, but the two events doesn't happen at the same point as the observer B or A, right? So therefore, this the two events, both observers doesn't measure the proper time interval. And then the question from Arjuna was, who measures the proper time in this case? What observer can do a proper measurement of this situation. Can someone give me an answer? Can you give it a try? Can someone try to give give an answer? Just quickly, it's okay to be wrong. Like we will see how it goes. Can someone tell me, what do you think? Who is the observer who can do a proper time measurement of this event? No one? So this is the case. So if you want to do the measurement with the same clock, and if the two events has to happen at the same point, the observer or the clock that is doing the measurement has to move with the object. Do you agree if I say like that? So just forget about the light, okay, the flashlight, because it's going at sea. It's kind of harder to imagine when it comes to sea. But just imagine, I have how to say, I have a rocket that is moving, okay? There is a rocket moving at 0.8 C, okay? And I want to, there are two stars, okay? Star 1 and star 2, okay? So if I want to measure how long it takes for this rocket ship to go start from star 1 and to reach star 2, now can you tell me where should the observer be in order to do a proper time measurement of this case? So I have the rocket ship moving at 0.8 speed and I have two stars. Okay, so the rocket ship starts at star 1 position, right next to star 1, and it's going right next to star 2. We want to get the proper time measurement of this event. Where should the observer be? Like what kind of what should be the position or the frame of the observer should be in such a case to do a proper time measurement? Can you tell me? So that's kind of easier than thinking about this. Anybody? Just can you try to just give me some answer? So to do the proper time measurement, for the observer, the two events must happen at the same point, or you can say he has to use the same clock, of course. Okay, we cannot do a proper time measurement by using two clocks. Okay, so can someone tell me? Nobody? Just give it a try quickly, because I have to stop sharp at 10 today. I have another meeting at 10. So we don't have that much time, and I want to discuss another interesting example before we finish today. So can someone quickly tell me where should the observer be?
On the rocket.
On the rocket. Why? Who said that? Was it Yapa? Who was it? Can you tell me why? Why the observer on the rocket do the proper measurement? Why do you think that is true? The answer is correct. So you have some confidence. Can you explain us? Even in Sinhala, that's fine with me, okay? You don't have don't think the language is an issue. So you can say it in Sinhala or English or whatever way it's comfortable for you. Okay. Who was it? Who gave the answer? I didn't see the I didn't see the highlighting. Can someone tell me why you think it's the observer in the rocket? Okay, since it's getting too late, I will just say it because for the observer in the rocket, it feels like he's at rest and the background, the star background is passing by, right? So if he's in the rocket and if he turns it on, just as he passes star S1, and if he waits at the same position, it looks like the star background is moving at 0.8c backwards, right? So then he can just wait there and stop the clock right when the star S2 passes by him, right? So now, the measurement that he makes is the proper time measurement for this. Okay, the two events happens at the same time for him. So is it an absolute measurement? Is it a constant? What do you think? The proper time measurement is not an absolute measurement, right? It varies, right? I mean, like uh, it it is a measurement done in the rest frame, right? Okay, so now in this case, if
Excuse me, madam, we can't hear you.